Hello, and this video is on lesson 5-3, where we talk about compositions. Learning targets are to write the composition of two functions, evaluate the composition of two functions, and this begins on page 84. Alright, it begins by saying that a composition of functions forms a new function by substituting the output of the inner function into the outer function. The function y equals f of g of x is a composition of f and g, where g is the inner function and f is the outer function. Inside the parentheses, we can see that we have the function g of x. And so this function is called the inner function. Since we have f on the outside, f of x is going to be our outer function. Let's begin with number 1. The tables show information about Jim's mowing service. Use the tables to evaluate each expression, then tell what the expression represents. Okay, so this table right here represents the function t of a, and I'll just write it up here for reference, t of a, and this table right here represents the function c of t. So if I want to find t of 4 is going to be my input, which means my input, when I'm looking for my inputs, they are going to be on the left side of the table. And so 4 is right here, and that gives me that the answer is 16. So what I'm looking for is tell what each expression represents. T of 4, what does this represent? Well, it represents 16 hours to mow 4 acres. That's basically what it is. And if I want to find c of 4, well, it's telling me that my input is 4. And when I evaluate it, what does 110 represent? Well, that tells me that $110 is the cost to mow for 4 hours. What about c of t of 1? Well, the first thing you want to do is begin with the inner function, which is t of 1. So we're going here. Here's my input of 1, which gives me 4 hours. So to mow 1 acre, it takes me 4 hours. Now I'm going to take those 4 hours, which are right here, and find what the cost is, because in the end I want to find what c is. That's my outer function. The outer function represents the cost. And so it tells me that it is $110. So notice that the input started with 1 acre, and we found out that it takes 4 hours to mow 1 acre, and from those 4 hours it cost $110. Here we have t of 4. So here's 4, it gives me 16, and once I have 16 hours that it takes to mow 4 acres, I need to take that 16 and plug it into the outer function, which is c of t, and c of t is going to say that for 16 hours it costs $350 to mow. Okay, so we're basically doing the same thing here. Again, here's our function f of x, and here are the inputs, and here we have the function g of x. And you're doing basically the same thing here. Number 3, using f and g from item 2, complete each table of values to represent the composite functions f of g of x. and g of f of x. Now notice this new notation here. Basically, f of g of x is the same thing as f of g of x. These notations mean exactly the same thing. Notice how the outer function goes first and then the inner function goes second. The same thing that we have here. The outer function is on the outside and we write it first, and then the inner function goes inside the parentheses and it's written second. So that's just a new notation. Very simple to get used to it. And so here, let's just do the first example. It's asking us to find f of g of 1. My input is 1. So the first thing I want to do is find what is g of 1. So if I were to write this out, f of g of 1, this is what it's asking me to find. So if I go to f of g, I mean g of 1, here's my function g of x, here's my input of 1, and I'm seeing that it equals 4. And so we have f of 4. And so now I need to find what f of 4 is. Here's my f of x function. F of 4, as you can see, gives me 4. And so f of g of 1 is going to equal 4. Okay. So this is how you fill out the rest. Let's do the first example from the other table. Here I'm trying to find fg of f of 1. Notice that this time my inner function is f of x and my outer function is g of x. Okay, so the first thing I want to do is, what is f of 1? Well, here's my function f of x. F of 1 here is going to give me 3. And so f of 1 is equal to 3. And now what I want to do is find g of 3. Here's my function g of x. Here's my input of 3. And it tells me that the answer is 2. And so my answer is going to be 2. And that's how you evaluate the composition of two functions. I'll leave it up to you to find the rest. For items 7 through 11, use the three functions f of x equals x squared, g of x equals 2x minus 1, h of x equals 4x minus 3. So the first thing we want to do is evaluate each expression. Notice here we no longer have tables to work with, but instead we have the functions themselves in equation form. So how are we going to evaluate this? Well, same thing that we did last time. Notice here in g of f of 2, my inner function is f of x, which means I'm going to start using this first and find what f of 2 is. So I'm going to take my input of 2 and just simply plug it in for x. And so what is going to be f of 2? Well, that's going to be, plugging it in for x, we get 2 squared, which is equal to 4. And so now f of 2 is equal to 4, and so we have g of 4. G of 4. So now my input here is going to be 4, and that means that since I'm using the function g of x, I'm going to plug that in for my variable in the function g of x. And so g of 4 is going to equal to 2 times 4 minus 1, and that is equal to 4 times 2, which is 8. 8 minus 1 equals 7. And so g of f of 2 is equal to 7. Let's do one more example. Here my inner function is g of x, and first thing I want to do is start with the inner function and work my way outside. So first thing I want to do is find what a g of 2 is. Same thing we did to find g of 4. We just simply plug in the input into the variable, and so g of 2 is going to equal to 2 times 2 minus 1. Notice how I plugged in 2 in for x. It replaces the x, and so we get 4 minus 1, which is equal to 3. And so f of g of 2 is equal to f of 3. Okay, f of 3. F of 3, again, we're using the function f of x, and we're taking my input of 3 and plugging it in for the function f of x, specifically for the variable x. And so f of 3, simply replace the x with 3, and then you have squared. So 3 squared is equal to 9, and so we get that the final answer is f of g of 2 is equal to 9. But, okay, so those are the answers. Let me erase this. What about when we start writing composition functions in terms of x? What we want to do is find, well, g of f of x. What is going to be the equation for this function? Well, notice here, instead of having an input, we have an inner function inside the parentheses. Here's my inner function, right there. What I'm going to do is, since we have our outer function as g of x, instead of plugging in x, what I'm going to do, let me use a different color. Instead of plugging in x, instead of plugging in a number like we did in number 7, I'm going to plug in the whole function f of x. That is exactly what I'm going to do. So the first thing, in order to transition into this easily, what is f of x equal to? F of x is equal to x squared. And so really what we want to do is find g of x squared. What is g of x squared? And so you're taking x squared and you're plugging it in for the function g of x, specifically in for the variable x. And so what that looks like, taking that in, you're plugging in for x, and so that's going to be 2x squared minus 1. Now we can simplify this, and so this is equal to 2x squared minus 1. That's it. That is g of f of x. And so what if we try to find g of f of 2? Is this going to give us the same answer? Well, let's find out. G of f of 2, all we have to do is take the input and plug it in for x. Okay, so we get 2 times 2 squared minus 1. 2 squared is equal to 4. 4 times 2 is 8. 8 minus 1 gives us 7. So yes, this does work out. And so g of f, or we could write it in the other notation, g of f of 2, or g of f of x is equal to 2x squared minus 1. This is my composition function. There we go. So instead of using two functions separately, we can use the composition function to evaluate it just one time. We want to do the same thing with f of g of x. So notice my inner function here is now going to be g of x. And g of x is equal to 2x minus 1. And so I can rewrite this as f of 2x minus 1. Notice again, we don't have a number to plug in, but instead we have an expression that is equal to g of x. And so what I want to do is my input is going to be this expression, and I'm going to plug it into the function f of x. Specifically, it's going to replace the x. Plug it into the variable, and so my function is x squared, and so f of g of x is equal to 2x minus 1 squared. I took this and I plugged it in for x. And this is what we get. Now we can simplify this by distributing, so we have 2x minus 1 times 2x minus 1. We distribute the 2x times 2x, which is 4x squared. 2x times negative 1, which is minus 2x. Then we distribute the negative 1 times 2x, which is negative 2x. And the negative 1 times negative 1, which is plus 1. Combine like terms, so we have 2x squared minus 4x plus 1. This is my function f of g of x. Composite function. Now, is this, when we try to find f of g of 2 using this composite function, is it going to give us the same answer that we got here, which is 9? Well, let's go ahead and find out. So we want to find f of g of 2. Everywhere I have a 2, that's where I want to plug it in for x. So everywhere I have an x, I want to plug in 2. So we have 4 times 2 squared minus 4 times 2 plus 1. 2 squared is 4. 4 times 4 is 16. Minus 4 times 2, which is 8, plus 1. Here we have 16 minus 8, which is equal to 8 plus 1, which is equal to 9. Take a look at that. They are exactly the same answer. And so instead of having two steps where you have to find what g of 2 is and then find what that answer is and plug it into the function f, you can just simply use the composite function f of g of x or g of f of x in order to find your answer using just one single equation. Here are some more examples where it asks you to find g of h of g of x and g of x. Just use the examples that we just did here, and that should help you find number 10 and 11. And if you need some more practice, you had lesson 5-3. Alright, thank you for watching.